Welcome back to another fun lesson of calculus. This lesson is so much fun, we're actually going to learn about something called the fun chart. Woohoo! Warning. The fun chart is a tool for you to help remember stuff. You must use more than just the fun chart to properly justify things. And I'll explain what that means when we get to it later in this video. So, the fun chart was basically born when we started to examine the relationships between f, its derivative f prime, and its second derivative f double prime. So we're going to break down each of these relationships so that they hopefully, quote unquote, make sense for you, and that way you'll have no problem remembering the fun chart and using it in problems. The first relationship goes like this. Let's assume that the derivative of f is positive. Okay, and so that means that f prime is greater than 0. This is positive. Okay, so we can, right, so f prime means slope of f, and so we know that the slope of f is greater than 0, which means, in another format, f has positive slope. And now here's the big jump. If f has positive slope, that means that f has to be like going up. So this thing here, this curve has positive slope, this curve has positive slope, this curve has positive slope, right? All of these have positive slope. They have the same word in common. This word is increasing. So basically, a function is increasing as long as its derivative is positive. And so this last step we're going to say is f is increasing with a sort of, you could put an arrow on it if you wanted to, but I tend not to. So these two things are the concise, shortened version of this line of thought. And so these two things are the things that go into the fun chart over here. So if f prime is positive, f is increasing. Now, just as a warning, the fun chart is something that like Mr. DRAM came up with and Mr. DRAM uses, and is not necessarily something that the rest of the general calculus population recognizes as being official, quote unquote. So this kind of notation where we say f prime plus or f increasing sign, that's not sort of commonly accepted. However, anything in here is a-okay to use, and people will understand what you're talking about. So really what you need to do is if you see f increasing sign on the fun chart, you're going to write in words that f is increasing because that's something that everybody knows what it means. Furthermore, every time you see f prime plus, you won't have to think through all of these steps. The goal is for you to be able to eventually, with practice and sort of thinking it over in your head, be like, oh yeah, if f prime is positive, then f must be increasing. That's basically the steps. So let's see if we can do the next bit. So it's very similar, right? If f prime is negative, well, then we can fill in all the charts, right? So, or not the charts, but the steps. F prime is negative means that f prime is less than 0, which means that the slope of f is less than 0, which means f has a negative slope. You see where I'm going with this. Which means that f is, what's a good word for functions that have negative slope that are going down, way down? How about decreasing, because that's sort of like increasing, but the opposite. F is decreasing, and so we have a symbol for that. It looks like that. If you want to put the arrow, you can put the arrow. But yeah, and so these are the two things, this minus and this decreasing, that will go into the fun chart. So here we'll have f prime minus and f decreasing. And so the fun chart's kind of nice. Like, this is the first half of it, and it's not that bad. And so basically, if you're looking for whenever f is increasing, and you have, for example, a graph of f prime, you're going to see where the graph of f prime is positive. Or vice versa. If you have a graph of f prime, wherever f prime is negative, that's going to mean that f is decreasing. And we'll see some examples of that later. Alright, now we're going to look at the relationship between f double prime and f prime. This is a little bit weird, but the easiest way to think of this is that f double prime is really the derivative of f prime. And so we can say that, well, if f double prime is negative, then f double prime is less than 0, so the slope of f prime, right? So this phrase slope of f prime means f double prime. And so therefore the slope of f prime has to be less than 0, which means that f prime is decreasing if f double prime is negative. So there's our f prime decreasing. So on our fun chart, we're basically going to take these same four relationships, shift them over and down because they apply to f double prime and f prime. If f prime is positive, if f double prime is positive, f prime is increasing, and if f double prime is negative, then f is decreasing. Okay, and so, right, because f double prime is the slope of f prime, and so you have the same relationship that you do with f and its derivative, f prime. So the last thing that remains is, well, if f double prime is positive, what is happening on f? Let's find out. Okay, if f double prime is positive, then we know that f prime is increasing. Okay, so f prime increasing means that the value of the slopes of f are increasing. Because remember, right, slope of f is f prime. And so if f prime is increasing, then the slopes of f are increasing. So let's say we have a function, and let's say we have a 0 slope. Okay, for the slopes to be increasing, the slopes have to be getting bigger. So now we have like a slope of like maybe a half, and then maybe like 1, and then maybe like 5, and then maybe like 10. And you see that in order for the slopes to be increasing, the function f has to sort of be like curving upwards in this weird shape. Similarly, right, if this is 0, the function will continue to curve upwards like this, because this slope would be like negative 10 and negative 5 and negative 1 and negative a half and negative, I don't know, etc. And notice that these slopes are actually, even though they're like negative, they're getting closer to 0. These slopes are increasing because they're moving towards the positive side, right? Negative 5 is more positive than negative 10, which means that to go from here to here, the slopes had to increase. I mentioned before that this sort of looks like curved upwards. That's not the actual word. The word for this is concave up. Concave up, because it's basically curved upwards. And if you want to add your smiley face, you can add your smiley face. Similarly, if f double prime is less than 0, that means that f prime is decreasing, which means that the slopes of f, because that's f prime, right? Slopes of f are decreasing. And so if you had a slope at 0, right, the next slope would be like negative and then more negative, and it would continue to curve downwards, and same on the other side. These would curve downwards. So if you had a slope of 10, then 5, and then 3, and then 2, and then 1, and then 0, you can see how these slopes are getting smaller and smaller and smaller and more negative. Those slopes are decreasing. So this is word concave down. Concave down. Or curve down. And if you want to add the shad face, you can add the shad face. On our fun chart, this basically happens to be if the f double prime was positive, f is concave up, and if f double prime is negative, then f is concave down. And oh, look at that! Oh, it is so much fun, you can't even stand it. But yeah, that's the fun chart. Put a giant box around that because we're going to use that. We're going to use that a lot in the next couple, years. We'll go over how to use the fun chart in a problem in the next video, but I just want to say something right now in this first one, and that is basically whenever one thing in a column of the fun chart occurs, for example, let's say that f double prime was negative, that means that all of these other things, so all of the other things in that same column are also true. So for example, if f double prime is negative, f prime is decreasing and f is concave down. All of those things are true if one of the things is true.